Section 1.2 Subsets, Video 2. In this video, we will cover the following objective: define subsets and proper subsets. We will start with a definition. If each element of set A is also an element of set B, then A is a subset of B. If set A is a subset of B, this relationship is denoted using this notation. It sort of has a look of a less than or equal to symbol, except for it is rounded. If set A contains at least one element that is not contained in set B, then A is not a subset of B. This is denoted using the subset symbol that has a line drawn through it. Example 2, determine whether each given set is a subset of the other. So here we have set A is the set containing the values 5, 7, 9, 11, and 13. And set B contains the values 1, 3, 5, 7, all the way to 21. Set A is the odd numbers between 5 and 13, whereas set B contains the odd numbers between 1 and 21. Notice that that each element of set A is also an element of set B. So we say that A is a subset of B. We could write that in words. A is a subset of B. Or we can write it using symbols. A is a subset of B. Because each element of set A is also an element of set B. Part B. Set A is a set of all X such that X is a person who lives in the United States. And B is the set of all elements X such that X is a person who lives in Illinois. Set A is not a subset of set B. Which can also be written symbolically like this. A is not a subset of set B. Now, why is that? Well, set A is the set of all people living in the United States, and B is the set of all people living in Illinois. There will be people in set A, people who live in the United States, who are not in set B, people who are living in Illinois. Not everybody living in the United States is living in Illinois. Part C. A is a set of all X such that X is a month of a year beginning with the letter J. And B is the set containing January, June, and July. If we write set A using raster method, these are the months beginning with the letter J, that would contain the elements January, June, and July. Notice that every element in set A is also an element of set B. In fact, these sets are equal. We can say that A is a subset of B. Or, symbolically, A is a subset of B. Notice that if sets are equal, we can say that one is a subset of the other because each element of set A is also an element of set B. Part D. A is the empty set, and B is the set of all X such that X is an element of the natural numbers and X is less than 51. In raster method, set B would look like this. We have the natural numbers that are less than 51, so it'd be the numbers 1 through 50. Now, since A doesn't contain any elements, by definition, the elements of set A are also in set B. So by default, we say that A is a subset of B, or we could say that A symbolically is a subset of B. Again, each element of A is also an element of B. A does not contain any element, or does not contain an element, so this is just true by default. So that gives us the statement here, the empty set as a subset. Given any set A, it follows that the empty set will be a subset of the given set. And as I mentioned when covering part C, equal sets as subsets, if given sets A and B are equal, then A is a subset of B and B is also a subset of A. This brings us to the next definition. Set A is considered a proper subset of set B if every element of A is also an element of B and sets A and B are not equal. If set A is a proper subset of set B, this relationship is denoted using this notation here, which looks like a less than symbol. Notice how the equal bar is missing. That tells me that sets A and B are not equal. If set A is not a proper subset of set B, then this relationship is denoted using that symbol with a line through it. Example 3. Determine whether each given set is a proper subset of the other. A is the set, part A. A is the set containing the even numbers from 2 through 12, and B is the set containing the integers from 1 through 12. Notice that each element of set A is also an element of set B, and sets A and B are not equal. This means that set A is a proper subset of set B. Which can be written symbolically like this, because each element of set A is also an element of set B, and this is important, and those sets are not equal. So you could look at it like set A fits inside of set B. They are not exactly the same. Part B. A is the set of all X such that X is an apple variety, and B is the set Fuji, Gala, and Honeycrisp. In this case, set A is not a subset of set B, and set A is not a proper subset of set B. In order for A to be a proper subset of B, every element of A would also have to appear in B, first off. And notice that that's not the case. A is a set of all apple varieties, whereas B is only a set of 3 different varieties. Certainly, set A will contain more elements than set B. And so we say that A is not a proper subset of set B, which can be written symbolically like that. Part C. A is a set of all X such that X is 3 times N, where N is an element of the natural numbers, and B is the set 3, 6, 9, ... So what is this saying here? N is the set of natural numbers. Or sorry, N is in the set of natural numbers. That means that n can equal 1, 2, 3, etc. And that means that we would have to fill those values in for n in order to build this set A. So if n were 1, then we would have 3 times 1, which is 3. If n were 2, then we would have 3 times 2, which is 6. If n were 3, then we would have 3 times 3, which is 9. So on and so forth. So this is an infinite set. It has no ending element. So basically this is saying that n can be any natural number. So we would fill the natural numbers starting with 1 and continuing on in for n in order to build the set using that formula x equals 3n. So set A is the set 3, 6, 9, and so on. Notice that set B is also the set 3, 6, 9, and so on. So it is true that A is a subset of B, because every element of set A is also an element of set B. But A is not a proper subset of set B, because with a proper subset situation, every element of the first set is also an element of the second set, and the sets are not equal. And in this case, the sets are equal. So A is not a proper subset of B, which can be written symbolically like this, because they are the same. They contain the same elements, which goes against the definition of a proper subset. Although they didn't ask us for it, I'm going to make a note. Note, set A is a subset of B, though, because with a subset, the only condition for one set to be a subset of another is that every element of the first set must also be an element of the second. So again, A is a subset of B, but A is not a proper subset of B. This concludes example 3.